All right, so we've got addition, subtraction down, and now we get to the easy versions, or easy operations with rational numbers, multiplication and division. So I thought about this, and I'll explain to you guys with addition and subtraction how this can work. Oh, sorry, let me first do just a review, basic ideas, and this goes for integers as well as fractions as well as decimals. Remember, if it's the same sign when you multiply or divide, the answer is positive. So a positive times a positive is a positive. A negative times a negative is also a positive. So ways we can show multiplication, don't forget the little dot, or we could do parentheses as well. If there are different signs, then the answer is always negative. Oops, negative, spelled correctly. So a negative times a positive, or a positive times a negative, your answer is always a negative. So this was what I was getting to. When you talk about multiplying fractions or adding, subtraction, or fractions, dividing, subtracting, whatever you're doing, if you think about how it works with whole numbers and kind of relate those to fractions, you can kind of maybe talk yourself into the actual, or almost to the operation. So when we think about whole numbers first with multiplication, well, let's turn these into fractions. 3 times 4 is 12, but how can we turn those into fractions? Well, 3 is 3 over 1, 4 is 4 over 1. Any number can be turned into a fraction if you put it over 1. And then think, if the answer is going to come out as 12 and I have to use multiplication, how do we do that? Well, it looks like we just multiply those numerators, and this might be a part where you kind of got to remember what operation you're doing, but in this case you multiply the denominators. For multiplying fractions, step 1, multiply the numerators. Step 2, multiply the denominators. And am I finished at that point? Chances are no. The last step, make sure you simplify. The unique thing about multiplication that isn't true with addition or subtraction, or division, is that actually the simplification step could actually be done at the beginning. This is the only operation where that's true. So we'll look at one here where you can actually do that. So this is my I do, one of the I do's. You only have one you do in this video in total. So we can do the step, the simplify first or the simplify last. If I did it last, first step is multiply the numerators. Second step is multiply the denominators. And then last step is simplify. So in this case, both of those are divisible by 3. So 2 over 21 is our final answer. Two positive numbers, multiply, simplify, there's your answer. The other thing you can do though, and you may remember giving this an actual name, is you can simplify first. And simplifying first involves cross canceling. Not to be confused though with cross multiplying. Cross canceling is done when you say, okay, across from each other, the 3 and the 9 both have a factor in common. That factor is 3. So if I divide both the numerators, the numerator and denominator here by 3, I can go ahead and take care of my simplifying ahead of time and then multiply and get 2 on the top and 21 on the bottom. It's your choice. Whatever you think is easier works for multiplying, but multiplying should be your easiest operation. So there's my example I do. The only you do is going to be a dividing a fraction. So again, I try to give you kind of ways you can think about it intuitively in case you forget, you're on a test and you forget, oh shoot, how do I divide by a fraction? What's the rule? Well, think about an easy example. Think about integers. What does division actually mean? What is 6 divided by 2? It's 3 because if I take 6 things and divide them into groups of 2, then there's 3 items or 3 groups. So what are you really asking when you're talking about division? It's how many groups of 2 are there in that first number? So if we change this to fractions now, and I chose these to be kind of strategic, we're thinking instead of how many groups of 2, we're thinking how many groups of 1/2. So I have to divide each circle into half to make a group. How many groups do I end up with? A half, a half, a half, a half. Well, my total ends up being 12. 12 groups. If I boxed in each of these as its own group. A half makes up each group. So how many different groups do I have? I have 12. So when you're thinking of the division, you're going to think, okay, how would I get 12 off of this? And the phrase normally taught at Indian Hill and a lot of different places for dealing with division of fractions, and when I say this, you probably remember it, is keep it, change it, flip it. The keep it, and it goes in order, refers to how are we going to turn this into 12? Well, 6 stays as 6. Change it, the division becomes multiplication, and flip it, and let's use a better word, let's use a more math word. We want to use the reciprocal. How can I turn that into 12? Use that as an operation that's going to give me 12. Well, I change that to 2 over 1, which is 2, and 6 divided by 1/2 is 12. So keep it, change it, flip it is your guideline, but you want to, again, think about it intuitively. What does it mean to divide it into halves? Well, it's to see how many halves go into 6. So there's 12 halves. So I did a pretty easy one, but hopefully with that information, I can leave you one that you try. So you might want to pause and try this one. I gave you a mixed number here, so the first thing you have to do, and this is kind of prerequisite for every single one of them, is you need to have, there are special occasions, special situations where you can use mixed numbers, but this is not one of them, not easily anyway. So what you want to do is change this into a mixed number, or sorry, change this into an improper fraction, so 2 times 1 plus 1, negative 1/2 is the same as negative 3/2. Now we want to keep our first term, change it to multiplication, and flip our fraction. What you notice is I'm not canceling, I'm not looking at cross-canceling until I have multiplication. Now I look at 2 and 9, nothing in common. Now I look at 3 and 4, nothing in common as far as factors that I can divide. So I know that I can go ahead and multiply. So this is 27, the denominator is 8, and our answer would be a negative value because a negative times a positive is a negative. I do want to show you something kind of interesting, and I saw some people use this as an alternative method. And if you feel good about that and you've got it down good, you can basically ignore what I'm saying here. But an alternative method, taking it from the point where you've turned them into improper fractions, so negative 3/2 divided by 4/9. Multiplication, division, I didn't say anything about common denominators. However, if you decided you wanted to do common denominators, this is kind of an interesting thing that I don't think I was aware of when I was in school. But if you change these to common denominators, so that would be 18. So times 2 for the second fraction times 9 for the first one. Negative 27 divided by 18 divided by 8 over 18. What you can actually do from here, if you have denominators that are common or denominators that will divide out evenly, you can actually do your division now across, just like we did the multiplication. So division, negative 27 divided by 8, well, I can't divide those two evenly. But I can do 18 divided by 18, which is 1, which if a number is over 1, we don't really care about that denominator. And look, we got the same answer. So just something else to think about if you want to kind of think about multiplication and division in the exact same ways. You just need to make sure your denominators will divide evenly. So hopefully this kind of jogged your memory and wasn't too long and painful. We'll practice this tomorrow and kind of wrap up fractions